All right, guys, so here's day 2. This is a Tuesday. Again, if I'm not here, I have a baby. So hopefully all is well with the first day of notes. You can dive into it. Remember, the answer key is in my bookshelf. You can always look at that if you need some more extra help looking through some of the answers to homework. Take out your worksheet from yesterday, and I want you guys to try this one out. You can try it with friends, get in groups or whatnot. I want you to try this one out, though. Set up the tick marks for the slope field. Take the actual integral. You're going to get a plus c, and then you're going to plug in 0, 0 to figure out what that plus c is, so you can find the actual path of the railroad track. So hit pause, try this out, and when you're ready to look, we'll look on the next slide together. Hit and pause. All right, so here are my slope fields for it. All I did was plug in all the points. If you notice, everything on the y-axis is flat because everywhere there the x is 0, and 0 divided by 1 is 0. So everywhere there's that. And remember, since there's only x's in this problem, then you should be able to remember that everything vertically is the exact same. So everything there was a 0. Let me try and move the yellow. Everything there was a half, 2/5, 3/10, negative a half, negative 2/5, negative 3/10. Okay. And then I have the town at 0, 0, so I have to drive my train through the town 0, 0. So to me it looks something like this might be the path. That would be the railroad track, and the train would go on that red route, pick up people at 0, 0, and then keep on moving. So my goal is to figure out exactly what that red equation is. Okay. Now remember too, I could draw many of these different paths, and they would all look like this. But the one that I really want is the one that goes through 0, 0. Okay. Now to get it, I want you to get used to putting that dx over on the right side. And now we are going to be able to integrate to get that path. The integral of 1 dy gets you y. Notice here, there is no exponent on the bottom, overall exponent. It's a 1. So right away, I'm going to write ln of x squared plus 1 plus c. And I'm going to be off by something. So let's see, the derivative of x squared is 2x. And I only want x, so I'm off by a half. Okay? So there's your path. All of those, the plus c's, are all of the greens and the reds. But I need to find the c that gets me the red guy. So to do that, plug in 0, 0. You're going to get 0 equals 1/2 ln of 0 plus 1 plus c. 0 equals 1/2 of ln of 1 plus c. 0 equals, ln of 1 is 0, so you get 0 equals c. So the official red path is 1/2 ln x squared plus 1. And that's it. And that should make sense why the plus c is 0 here, because that c just elevates or lowers your path. Well, I didn't move it off of the axis, so it should be 0. Okay. Here's some homework questions that I thought you guys might have. One of them was 7, and you had this big ugly guy, and you needed to show that it fit some sort of y prime equation. Okay, so just a little bit of the details of it. It's a multiplication, so it's a product rule, so I have to take the derivatives. So there's u and there's v. U prime is easy. V prime, stamp address. Now notice that stamp address looks huge. Okay. And then when I place that into who y prime is, I got y prime is u prime v plus uv prime. That looks super messy, but the nice thing is that yellow highlighted second part of the product rule. Stare at it for a moment. All I did was on that very top up here, what did I factor out of the top of this? A secant x. So I put that out there. That helped me see that the tangent x plus secant x over the secant x plus tangent x cancels. So if those cancel, that goes away. And cosine times secant, cosine of x times secant. Secant is 1 over cosine. So that cancels down as well, and you're left with a minus 1. So that's kind of nice. Now I still need to get the second derivative as well. So I need to do another product rule. So I have u as sine x, u prime is cosine x. V is ln stuff, stamp, address. The derivative of -1, that yellow part goes away. So here is where my goal is to plug in y double prime plus y, and I hope it equals tangent. That's your goal, is you hope it equals tangent. So take a look at it for a moment. Remember too, when you put in this y double prime, there's going to be a cancellation. So let's stare at that. Whoa, messy. Okay, the y double prime plus y. Let me put this in here. I don't know why I didn't put the y double prime in. Would be cosine x ln of secant x plus tangent x. And then you're going to be left with plus sine x secant x. This part, again, just goes to a secant x. So then that, all of that y double prime, let me kind of do this for you instead of making it already pre-established. My goal is to force, hopefully, this equation to be true. So my y double prime is cosine x ln of secant x plus tangent x plus sine x secant x. And my y way up at the top is negative cosine x of that minus cosine x of ln of secant x plus tangent x. And I hope that all equals tangent x. All you did was, that's y double prime, that's y, and I'm trying to see if it equals tangent x like it is supposed to. Well, hopefully you notice that the cosine tangent, the cosine x there and the negative cosine x there cancel. So I'm left with sine x secant x equals tangent x, I hope. Then secant x is sine x over 1 over cosine x. And so I have it as tangent x equals tangent x. Now you might be like, what in the world are we doing? Okay, there's a huge class in college called differential equations. We are doing 1 week of it today, or this week. Differential equations is so important, and they come up with equations like this, and your goal is to come up with what y makes this work. And it's huge applications in engineering. What this problem today showed you was giving you this y, show that it fits. In differential equations, another class, think of it as Calc 4, I will only give you the green and I'll say find the y. You do not know how to do that right now, and you don't even know why it's important. But what you do know how to do is, if I give you a y, you know how to prove that it does make the green work. Okay. 39 was another one that I thought you guys might have questions on. It gave you all of this info, and it says, I want C1 and I want C2. Okay. So this is kind of being able to manipulate. Basically, these are practice problems, making sure you can manipulate first derivative, second derivative, plugging in, making sure you're okay with things. So what I first did was I said, okay, I'm going to use this red info. X is 2 when y is 0, and I wrote that equation there in red. All I did was plug in 2 and 0. Now, I want to plug in 2 and 4, but the next guy is for y prime. So I don't have y prime yet, but I can take this guy, and I can take his derivative, and I have y prime. So if I have y prime now, I can plug in 2 and 4 into that green equation, and you're left with that. So now you have 2 equations and 2 unknowns, the red equation and the green equation, and you should be able to solve for the C1 and C2. So I did that right there, and I got C1 is -2, and C2 is 1/2. So I was able to find those, and I can plug that in to this yellow equation up top. Now that I have the yellow equation, my goal is to take that yellow equation, and I want to prove to the world that this yellow equation will make this work. So what I need to do is I need to find y prime, which I can do. Y prime is -2 plus 3 over 2x squared. I also want to find y double prime, which is 3x. And my goal is I'm going to plug in that y prime, and that y double prime all into the green equation, and I want to show you that it equals 0. So I want to show you again that it equals 0. So if you want, you can do that. Let me see if I can quickly do it here for you. I'd have x squared times y double prime minus 3x times y prime plus 3y's, and I hope that equals 0. So your goal is to see if that cancels everything out to equal 0. And let's see here. This is going to be 3x cubed plus 6x minus 9 over 2x cubed minus 6x plus 3 over 2x cubed. And again, I hope that equals 0. The 6x's cancel. That's nice. And I got, let's see, 3x cubed minus 9 over 2x cubed plus 3 over 2x cubed. Let's see. Let's just do it with numbers. 3 minus 4.5 plus 1.5 definitely equals 0x cubed, which is 0. And what would this question really ask in differential equations? It would only give you the green, and it would say, find me the yellow. For you and me today, it is, here is the yellow, show me it fits the green. There's another one here, 3. Last year someone had a question on that. You can take a look at this on your notes if you want, because they'll be up on on the internet as well, on the website. All right, so some of those questions in the homework might have felt random. To me, that was some practice on seeing differential equations. Our ultimate goal, though, is problems like this one, where I give you a slope field, I make you show the ticks. Once you show me the ticks, I might give you a city or a little town, and I want you to find the path of the railroad through that slope field or through that terrain. Those are the ultimate questions to do. Now, everything we've done yesterday and everything that I've showed you today, meaning this warm-up problem, has X's in it only. I have not really taught you how to handle it if there's a Y to it. So today, our focus is how to solve differential equations that involve Y's. And remember, a differential equation, all that means is your dy over dx equals something. It's your slope field guy. And my goal is to take that slope field guy and take the integral of it. And today, I'm going to do it with Y's. And the technique to solve this is called separation of variables. So I'm going to teach you how to do separation of variables. Once I teach you how to do that, I'll do some application problems with you guys. These application problems are straight out of your Algebra 2 book, but it's with the calculus involved. You have done Newton's Law of Cooling in Algebra 2, or college algebra, or maybe pre-calc. You've done growth and decay. I'll show you how those were formed using calculus today. Decay and today, that rhymed. All right, so yesterday, take out that packet again, and we had this problem where you had dy over dx equals y, and I told you if you had a train just above the axis, it would follow the green path. If you had a train just below, it would follow the red path, and if you had a train exactly on the axis, the slope is flat, so it would stay flat. And the big difference about these problems versus everything that you've done is these look different. It doesn't just look like a guy where you add a plus C. They feel different. The green guy looks different than the black and looks different than the red. So to solve it. I'm going to show you this up front, exactly how to do it. So I first told you we want to break it up and do dy equals y dx. And normally, I'd say let's integrate. But here's the issue. I can do the left side. The integral of 1 dy is y. The issue is here. I'm expecting x's, but I have y's. So I can't do that right now because it's supposed to be only in terms of x, and there's a y there. So the key to solving this problem is the term separation of variables. I want that y, all of the y's I want there, all of the x's I want on the right side. Then I will be able to integrate. So when I set this up, let me write that part again before I integrate. dy equals y dx. I do not want to integrate that yet because I have not moved the y's over. So to move the y's over, you divide by y, divide by y, and you would have dy over y equals dx. Now we can integrate because now all of the y's are on the left side and all of the x's are on the right side. Now this time has a 1 on the right, and the integral of 1 would be x. But normally whenever you integrate with x, you always say x plus c. Now look at the left side. I know it's in terms of y, but it's a guy you know how to do. The integral of dy over y. There is no exponent on the bottom, so it's a y to the 1. The derivative of y is 1, so that's a perfect fit. So you can just say this is ln of y. So I got ln of y equals x plus c. If you want to get rid of the ln, you can e both sides. And e to the ln just gets you the y. And you're going to have e to the x plus c. All of that. It's e to all of that. Very important property that you might stare at for a moment and go, I don't get this, but you better get it throughout the rest of the day, is that can be broken down into e to the x and e to the c. Okay? E to the x and e to the c. And this here is just a number. I don't know what that number is yet because I haven't forced you to plug in a specific town, but it's just a number. So if it's just a number, I might as well call it a number. That is still just a number. Now the part that might bug you is you see this C and you see this C and you go, are those the same C? Okay, e to the C is a number, C is a number. They're both just numbers. I don't know what the number is yet. I will never know what those numbers are until I plug in a village or until I plug in a town. So if you really don't like how I wrote two C's, could you write it as DE to the X and say D is still a number? Okay. I just showed you a huge preview of what we're doing today. If you're like, whoa, I don't get it, it's okay. We'll do another one. We'll do another one. We'll work through it all. The big thing to notice though is if you have y equals c to the x, if you want to graph those, if c is positive, the graph looks like this. If c is negative, the graph looks like that. And if c happens to be 0, the graph looks like that. So it fits my options that I had up here where it bent up and it bent flat and it bent down. One notation that some of you might have gone, where did it go? When I told you this goes to y, it technically goes to the absolute value of y, but I'm going to handle that absolute value with the c. So since it's an absolute value, that absolute value can kind of get hidden for a while until I plug in a specific town to solve for that c. And I know right now I'm not here. I know right now you want to ask questions, and I know right now you're like, I'm lost. Well, remember, this is only video 1. We got a couple more to go. Video 2 coming up.